G'day everybody and welcome back. You would have seen in previous videos when I go to use Morse taper drill in the mill, especially if it's a Morse taper 2 drill, I've got to use this Morse taper sleeve, MT30 Morse taper 3, with a sleeve and then the drill. A couple of times I've been sort of running real close out of room on the Z height, and I don't have a riser block for that mill. So what my plan is to build another one of these. This is a bought one obviously, but build one with a Morse taper 2 up its dot. I've gone ahead and done a Morse taper 2 without the tang on it, just machine one up so I can test fit it, you know what I mean, make sure I'm getting good contact. I'd set, when I made this one, I set it with the sine bar, so it should be spot on. Got a piece of material that's about 1/2 mil longer than what it needs to be, so I haven't got much material to play with. I'm hoping by the time it's done, I'm going to gain from this setup to the new one. Hopefully I'm going to gain around 35 mil, possibly 30 to 35 mil, I think, roughly. I hope, which will make a big difference. Also, I do have to make another 30 taper arbor for another project I'm going to be working on after this one at this stage, plus a 40 taper arbor. So there's going to be a few arbors coming up. So hopefully this one won't take long to smash out. Anyway, hope you enjoy. Okay, the largest diameter on this arbor is 50 mil, and that's 50.7, well, it's 2-inch. Just going to skim the outside, bring it down to 50, and then I'll turn the end portion down to 34 mil. I can't remember how long it had to be, but let's check the plans again. I do have a proper set of plans for this. So for a length of 36.5 has to come down to 34. Stuff around the speeds and feeds a bit and try and get a chip breaker to happen. I'm going to go for a fairly big deep cut. See if I can get that chip breaker to go a bit better. That's what I like about when you're playing around with speeds and feeds. Like, that was busting the chip, but man, it was pretty crap chip. You know, I probably fed it a bit hard. Finally got it to bust properly. 34. So when I go to put this in the 4-jaw, I can hold it on this diameter and clock off this diameter as well. And it should all stay pretty concentric, I hope. Okay, I've run a 7mm drill up there, fairly deep. I'm going to run a 9/16 drill, 75mm up from this end, and then I'll have to open up with a boring bar the very end of it up to 14.5mm. This should go that close to 14.5, it probably won't even be worth boring it. And then I can start putting the taper in with a boring bar for the Morse taper 2. I'm going to be using the tailstock DRO to get me depth on this, so that's going to be a handy thing. Zero that, we're right to go. I've ran out of quill, so what am I, 1.5 mil short. So that drilled out to 14.36 roughly. So long time viewers remember I got these sine bars from Tangent Engineering, Tangent Jim. And I got the discs, they're already pre-ground to the precise thickness to do all your Morse tapers. So this one's number 2 Morse taper for 4-inch sine bar. Set that one up like that, indicate it in. Probably going to be glary, but I'm going to call that good enough. Like it's probably a 1/10 over 4 inches. I ain't going to worry about that. I wouldn't say it's the best finish in there, but I may get away with it, but I may have to order a Morse taper 2 ream. Okay, I know this isn't the right thing to be doing, but anyway. I've got a couple of these sleeves, so if it does mark the end of it, I'm not concerned. It's wanting to get stuck in there, which is a good thing. And I know it's a crap finish in there, I'm well aware of that, but we have contact all the way up to here. So the angle's right. Okay, off camera I have played around with this taper a bit more. As you can see now the drill won't lock up because the tab's got nowhere to go. Just took it out of, yeah, another couple of fine cuts and then polished it up again. So now when I put the slot in for the tang will work. Before the drill was locking up, so the tang wouldn't have worked. So I didn't have it quite big enough. But I've rectified that. I just took a slight brush off the end here, just to clean that up. Right to spin it around now and clock it up in the forge jaw the best I possibly can. Indicate off this surface here, because I know that's concentric with the bore here. Indicate in the best I can and start putting the 30 taper on the other end of it. I don't know whether you can see in there or not. Don't look too bad. Definitely not my finest of machinings in there, but it's going to do the job. Now I'll get this chuck swapped over and run from there. Okay, that's something I don't normally show, is setting up the forge jaw, but I am well within half a thou on that end there and absolutely spot on down here. I'm going to start machining that 30 taper on this end now and we should be good to go. So for a length of 69.85 from this face, I've got to take it down to 31.75. That's the large diameter of the MT2 So I've touched off on the end, obviously touched off on the side here, as you can see. Terrible chip control there, one would say. Bit of a fiddle and we'll get it right. I hope that answered some questions I've been getting in the content and the comments about how do I get a chip break, chip breaker happening. All I do is just play with the speeds and feeds and the depth of cut. You could see when I first started there, it wasn't chipping, it wasn't breaking a chip. I increased the depth of cut and slowed the feed off a fair bit, and yeah, it's just working straight off the bat. So that's how I do it. It's just trial and error. If that didn't work, then try a bit less depth, bit more speed, vice versa, until you get it right. So I hope that answers the question. Like, that's 1.5 mil depth of cut, so yeah, 3 mil off the diameter, and we'll see how it goes this time. It may not work, I might have to adjust it again. So I've still got another 10 mil to come off this diameter, so I'll bring these guys back when I'm getting closer. In theory, that should be 31.75. Well, we are 31.77. I'm going to leave it right where it is. I was going to do this taper now, but what I think I'll do is drill and tap the M12 thread in the end first. .52, good enough. This is the only M12 tap I've got. It doesn't have a center in the end of it, so I'm just going to tap this off camera by hand. I thought I had a spiral tap, but I didn't. Okay, I started tapping that by hand. I'm not going to finish it off now. I'll wait till I can get it out and stand it up, and I'm worried about breaking the tap. I'll finish that off after. Just got to remember to finish it off. What I'm going to do now is reduce this section down here to 17.15 for length of 20.57. Probably don't really need tailstock support, but I'm going to use it anyway. In the right gear, Dick. .01 under. Bugger. Rightio, I'm about to set up to do the ISO30 taper. So I'll be using the sine bar again. And I covered this in a previous video. If I remember, I'll put a link to it in the description of how I work out the gauge block stack height and using the carbide depot calculator. So to do the ISO with a 4-inch sine bar, you need 14.66 mil gauge block stack height, which I've got here. Obviously got the compound loosened off. I'll get an indicator set up and start sweeping that in. Okay, so we're getting close there already. So I just normally just bump it in by hand, then I snug it up a little bit and just use soft hammer just to tap it in. I get it close as I can with this indicator and I'll swap over to a half thou indicator. It's just what I normally do. Okay, I am pretty certain I've got that on the money now. As close as I can ever get it anyway. It's going to do. Rightio, I am set to cut this taper. I'm going to do it all with a TNGG insert. We're getting very close there, looks pretty darn good. Nice surface finish. I'm going to leave it at that. There's no wind. It's bad. I believe it'll fit, no dramas. Rightio, this can come out of here now. I'm pretty confident I've done everything. Okay, I've probably snooked forward a bit here, but I've set the dividing head up and going to use the tailstock because I can. It probably does need it. I'm not too worried if I put a mark in this off the jaws. That is the centre. This slot has to be 6.7mm wide. Okay, that is out to width. So I'll index at 180 degrees and do the same again. that, in theory, is the slot done for the tang. It'll obviously need a little tiny deburr on the top here, but I'll index that 90 degrees now and put the dogs in. They have to be 16mm wide, fraction over 16mm wide, and down to this taper level. I need to go out fraction over 3mm each side. I can rotate that 180 degrees and do exactly the same on the other side. Don't look too bad. Have a tidy up with a file on these edges. I'm sure look Mickey Mouse. Okay, I've had a fair clean up here. See if it's dogs fit well. It's a good start. And they don't bottom out, the flange isn't bottoming out, so I've got the height right. Well, half right. I'll put an indicator on that outer diameter and see if there's any run out on that. Hopefully there's none, or very, very minimal. Righto, hopefully you can read that dial. So 0.01 run out on this flange. Anyway, I'll stick a drill in there and see how it runs out. So this is a 5/8 Morse taper 2 drill. That's alright. It looks alright by eye. You would think this section here would be concentric to the Morse taper. A 0.03 run out. 0.025 or something run out. Sorry about the shakiness, I'm shooting this bit on my phone. I didn't, in the video, I didn't put the indicator up the end of this, like in the Morse taper. So I've just, as you can see there, that's set that on 0 as close as I can. This is bad footage. So, what are we? About 3/4 of a thou run out. It's a 1 thou indicator. That to me is not too bad considering it was turned around and clocked back in the like on the lathe, so I think that's acceptable. Plenty good enough for what I want to do anyway. You'll have to excuse that wind in the background, it's blowing its dot off here. Blow a dog off heat. So the biggest reason I wanted one of these is you can see the height difference there already. So if I set this up, yeah, so if I go from that taper, bottom of that taper to the bottom of this taper, it's 45mm I've saved in length, roughly. So that's a lot of room, which is going to be a great thing. And it's going to run, definitely going to run true enough for what I do here. So I'm really happy with the way that turned out. And a massive thanks to Barry for whacking up the plans for me. Really appreciate that, mate. Anyway, I hope you enjoyed that. I thoroughly enjoyed building it, and hopefully I'll see you on the next video. Thanks for watching, guys. Hooroo.